Total mass. Work done by gravity में है. Total mass कितना है?
M. Total
mass कितना?
Stringham time.
M. M into Y naught. 2M or M?
Sir, M.
M.
M into 3h by 3. Gravity is what doesn't have any mass?
Not is like
M into 3h by 3. M into 3h.
Sir, why can't we do this by F restoring method? Like when it's displaced down by distance of x, both the left and right hand will also go down by distance of x.
There is a problem. See the equilibrium condition.
But in the same length it will go down by distance of x.
We will deal with the displacement of this ball. If this goes down by something, how much will this go down? How much will this go down?
So it will be equal to much, sir. If it is in this way initially, this will be the SHM. In the same way, this will not move by this way. Because there is no.
K of both are not the same here. If I displace 1 by x, or both should have the same displacement, both should have the same K. Restoring force will be different.
So it won't be just K. So I have a link.
Wait.
Sir, in this one, find the T
Equivalent provided A.
near that problem.
The formula that we defined, coefficient of tension whole square by K equivalent is equal to sigma of coefficient of tension whole square by K. We have the answer. The point at which gravity acts straight on. Make it fast, take it down.
सर वो जो आपने वर्क डन बाय एक्सटर्नल अपॉन वर्क डन बाय ग्रेविटी लिखा है उधर n into 3x by 2 है कि what is that before 3x by 2 in the numerator?
Mass. M into y naught.
Okay.
The value. Y naught is 3x.
Okay. So shouldn't it be mg into y naught?
mg.
Sir,
हाँ
so in the previous question, sir, so won't the spring bend and we have to take the component of
small
plates.
displacements. Small displacements.
Okay, sir.
Yeah, adjustment of variables ध्यान से देखिए if you have solved this problem. Simplify this, you get the answer. Next step is your answer. Bring that m1 plus m2 to the denominator, you get the answer. This is the pseudo force on the block. This is the pseudo force. If you have solved this problem, you will know what it is. The last exercise problem. Can I rub the board? Make it very fast.
Right.
So it should be omega square.
This one.
Yes.
What is
This is I1 omega 1 equal to I2 omega 2. Conservation of angular momentum. L initial is equal to L final. L is I omega. I is mr square.
So,
Huh?
so I had a doubt in superposition of waves. That if the equation has a different omega, how are we supposed to superpose them?
That is called beat phenomena. It will be explained in waves. You have one problem even in your booklet based on it. When will the two come in phase again? Right? We'll explain that with waves.
Okay, sir.
Sir,
Huh?
sir, in the 20 problem, sir, we are pulling the mass M1 so that it performs small oscillation. So, sir, how is angular momentum conserved?
You are pulling it through the center. Torque about the center of the circle is 0. So angular momentum can be conserved.
So,
Huh?
and sir, in the previous problem, sir, that spring with spring constant K moved by 2x and the spring with spring constant 2K moved by x, so that was the clear, sir. Can you explain that?
One is K, the other is 2K. When you are applying the same force, how much will the spring constant of K move? 2x. Because the restoring force on both should turn out to be the same finally. If not, the body will not be in equilibrium. It will be rotating.
It's not good.
You take the sixth question wrong here.
नहीं सही है फिजिक्स का बुकलेट है भाई साहब ये ध्यान से देख लो that the one spring is cut into 3 parts and placed. One spring is cut into 3 parts and placed.
Sir, in the previous question, Sir, how did you get the mg equal to 40x?
How did I take?
Mg equal to 40x.
Equilibrium condition, mg downwards, here k into 2x, here 2k into x. mg
Sir,
will be,
but it is not an equilibrium.
it comes down to equilibrium position where from the equilibrium position you will set it into oscillations.
d2x by dt square.
Omega dash is substituted.
d2x by dt square.
Due to r minus x.
So even down. Down.
Copy.
Last.
Problems just for the sake of problems here. They will not actually test any concept here, just to trouble you people. Huh?
So can you solve the 10th question also except for
Yes. Energy conservation.
2m and m.
The N 12 and mu 2. So M and 4.
This line is given as L, right?
No, sir. So 1 is L and 1 is 2L. So that will be L by 2 and this one. So the upper part will be L by 2 and the lower part will be L. Yes, sir.
I'll just make one small change here. I'll take this as L, this as L, this is L and L. You people solve it because I solved in my notes using that values. Right? You people take 2L and L by 2 and L by 2 as given in the question. Right? L minus 2 mu G into L minus X plus mg into L plus into the question. Okay? 2 mu into 2L plus mu into 2L. This is mass into acceleration. This I shall have to write it to the left. This is total mass 2 mu into 2L plus mu into 2. Mu into 2L into it. Bring this to the denominator and simplify, you get the answer. See, it's like this. You have pulled this slightly down, this above, and you released. It will oscillate this way. When you pull this slightly above, this weight will be greater than this weight. That's what you have put. L to L mu mg, just adjust it. I have taken L on both sides so that this will be the value. Now in the question this is given, this is L, this is L, this is L by 2 and this is L by 2. You make the changes accordingly. Take down the hint, you will get the answer once you solve it. People who have not solved it, please take down the hint. Make it fast. Make it oscillating.
Sir, can you show by energy also?
Loss in potential energy is gain in kinetic energy. Same thing. Right hand side potential energy. Equation will turn out to be the same. Right hand side potential energy increases. Left hand side potential energy decreases. Difference will be equal to half mv square.
Sir, in exercise 4th, first question, how are we going to take average speed?
Total distance by total time over one complete time period.
Sir, can the system not move like a simple pendulum? Because when I tried the sum for the first time, I thought that it would move like a simple pendulum when I solved it, so I didn't get
I also
that.
realized this right now when one of the students here tells me I have solved it using simple pendulum. Next time I'll make sure that in the print of that question it goes that not to be treated as a simple pendulum. Like the problem whoever designed didn't want it to oscillate this way. He says this is pulled up slightly above in this. Right. And for simple pendulum
Okay, sir,
there
thank you.
is one single point of suspension. Avoid this. But then you may say he didn't give us the radius. Right. I realized that just now. I'll make that correction in the question so that students don't interpret it that way.
Sir, 6th one.
So in the sixth one, when you are taking this like this is theta and this is fixed. You are taking small m to the mass of ice. Energy relation will be equal to half small m v square plus half capital M v square plus half I omega square plus half kx square minus mgx plus x naught sin theta. Sorry. Minus mg x sin theta, and this will become half k x plus x naught whole square. From the equilibrium it went down by a distance of x. Now the critical catch is I will be 2 by 3 capital M r square. Omega will be V by R because the body is rolling. Now this is the total energy. dE by dt should be 0. Now for ice, if this body turns out to be ice, the energy relation will be half small m plus capital M V square plus half I omega square plus half k x plus x naught whole square minus mgx sin theta. I will be 2 by 5 small m plus capital M r square. Omega will be V by. That is for ice, this is for water.
Sir, in the first case, why I will not be 2 by 5 m plus m r square?
What is the name of the chapter in which moment of inertia was defined?
Rotation dynamics.
Arey nahi, another name. Rigid body dynamics.
Rigid body dynamics.
Water, is it rigid? They intentionally play with the students.
Yes, sir.
You have got even in rotational dynamics questions like there is a sphere with water, this is rotating with a velocity v. What is the kinetic energy? Kinetic energy for the water will be only half mv square. Half I. What is the moment of inertia for water? Not defined. Moment of inertia is defined only for a rigid body.
सर सर एनर्जी इक्वेशन में माइनस कैपिटल एम जी एक्स साइन थीटा भी आएगा ना?
Minus capital M. Minus is right. Here also minus. This should be small m plus capital M. This should be small m plus capital M. Small m निकाल के small m plus capital M. Both are going down.
I should have taken the hollow cylinder.
Cylinder. Have a look. This is for a cylinder. This will be mr square by 2. Right? This will be for a. There's a hollow cylinder is mr square. Solid cylinder is mr square by 2. I took a sphere by chance. It's a cylinder. Make the correction.
सर
सर तो फिर यहाँ पर आइस के लिए सर जो आई ओमेगा स्क्वायर है वो 2 बार लिया जाएगा ना, एक बार हॉलो सिलेंडर के लिए और एक बार सॉलिड सिलेंडर के लिए.
Hi, solid cylinder of mass small m plus capital M. Hi, hollow cylinder of mass capital M.
So it should be mr square by 2 plus mr square, no?
Hollow cylinder mr square ही है ना यार.
So but the density is not uniform when the ice freezes, water freezes. And answer.
Density is? Density से क्या लेना देना है मुझे? Solid cylinder का.
He is considering that the ice on the cylinder and the capital M in the hollow cylinder itself, and we add the moment of inertia. That's what she's suggesting. I mean, since the densities are
Okay, she's saying the hollow cylinder का moment of inertia separately लूँगा, solid cylinder का moment of inertia separately लूँगा.
But that makes sense.
Yeah.
That makes sense.
Listen.
Yeah.
Small change here.
Right.
Write this separately. Add them up because
Capital M.
half I omega square for the hollow cylinder is mr square plus half I omega square for the solid cylinder is small mr square by 2. Hollow cylinder का ये जो mr square as it is लिखिए. Solid cylinder का add capital I small mr square by 2. So ice का when it is converted to solid cylinder this will be the value. Hollow cylinder I will be mr square. Add both the I is right. Hollow cylinder plus solid ice.
You have already extended.
So can you please discuss question 2 of this exercise?
1 second.
अच्छा हाँ but it's correct answer. Because I got
Fourth question of exercise 1. Ring of 18th, ring of diameter 2 meters oscillates on a compound pendulum about a horizontal axis passing through the rim of its passing through a point at its rim. Oscillates at the center is moving in a plane which is perpendicular to the plane of the ring. Perpendicular to the plane of the ring. That means this is oscillating axis. The ring is not oscillating this way. The ring is oscillating perpendicularly out and into the board. Ring is not oscillating this way. It is oscillating perpendicularly out and into the board. Right? So this I will be mr square by 2. This will be mr square by 4. Time period is 2 pi under root I by mgr. Parallel axis. Okay. mr square by 2 plus mr square. So I will be 3 by 2 mr square by mgr.
Sir? Sir, can you please state problem number 18 of exercise 4?
Problem number 18. Okay.
So is the oscillation 19?
one coming.
So in 18th one is the oscillation due to the spring or
Both. Time period of both.
In the
18th of exercise.
सर एक्सरसाइज 1 का क्वेश्चन नंबर 43 भी करो ना.
Exercise 4 18.
Sir, can you explain why did you take mr square by 2?
Parallel axis theorem. In a ring, in this plane it will be mr square by 2 for a ring. I want the moment of inertia about this axis, so I should take this as Ig plus md square. The ring is not oscillating this way. This is not the axis. If this were the axis, then I will take mr square, and this would be mr square plus mr square. The axis is this. The ring is not oscillating this way. The ring is oscillating this way. Hence I need about this axis. So I will take Ig to be this axis.
Okay, thank you, sir.
Now listen. For this, I take this to be small m, this to be capital M, this to be K. If this comes down by x naught, this will have x naught by 2. Total energy is half small m v square, half capital M v by 2 whole square, plus half k x naught plus x whole square, minus mg x minus capital mg x by 2, plus half capital mr square by 2 into omega square. Omega will be b by r.
So what is x and what is x naught?
X naught is the distance is moved to come to equilibrium. From the equilibrium you displaced it by a distance of x.
Sir, x by 2 or another x naught. So x and x not again makes note.
X naught is the distance it took to come down to the equilibrium position. From the equilibrium you displaced it by a distance of x and w.
Sir, but we need to answer in terms of I now.
Keep this as I then. dE by dt should be 0. dE by dt is 0. This will be R omega, which will be equal to V.
So I have an alternative solution for the 40.
Sir,
1 second, wait.
The resultant acceleration in SHM is m omega square a sine, and so we keep the observer here, so the acceleration on this, the pseudo force will be in this direction. So the cos 60 component will be equal to the friction. We can consider that.
Resultant SHM acceleration here. So you're taking both.
H much more greater than R. H much more greater than R.
The spring will be moving sideways also, right? So that we don't consider.
Spring will not move sideways.
No, because
This will rotate, this will is connected to the
Okay,
center.
sir, sir, exercise 1, 20 and 20, 19 and 31st.
Sir, 43 question also of exercise 1.
Sir, doubt in this question, sir. Sir, can we assume the mass M is connected to the pulley and change accordingly the moment of inertia and all?
Not an issue, you can pick up this mass and place it here. You can.
Okay,
Sir, exercise 1 45 also. 45.
Sir, 26 also.
43.
Sir, the answer is not coming by that matter, sir.
Which one?
Sir, by attaching the mass to the pulley, sir.
You will get. It is the same.
Sir, 41.
Only thing, do take the loss of potential energy also into consideration. When this is oscillating, this will be cut down. Take that vertical height also into consideration.
I'm not matching the 21.
This is one.
Yes, sir. T by DADAR.
Sir, 41.
First, let us complete this.
Sir, 25 also, please.
Okay. 19. Potential energy is minus ax square plus bx to the power 4. F is equal to minus du by dx. Plus 4bx cube should be equal to 0. This will be minus. Right? Now, one x is equal to 0 is one answer. The other x square is 2a by 4b, a by 2b. Now x will be under root a by 2b. I'll call this x naught. You have two values of x naught at which the force is 0. Now one which is in stable equilibrium alone will perform SHM. How do I know that? d2u by dx square. I'll get that as 2a minus 8bx.
X cube was there.
X cube was there, sir.
12b x square. Now put x equal to 0 and x equal to under root a by 2b. When I put x equal to 0, I will realize that it will not be stable equilibrium. It is for this value that there will be stable equilibrium. Right? So now when you take this force, net total force, what are you taking?
सर आपने वो माइनस d2u by dx स्क्वायर लिखा है
So du by dx means this will have a negative sign, this will have a positive, right? Okay. Now f is equal to 2a x naught plus delta x minus 4b x naught plus delta x whole cube. Am I right? Now this will be equal to mass into acceleration. So this will be 2a x naught is under root in the last step you can substitute the value of x naught. Equate this to mass into d2 delta x by dt square. Simplify that, you get the answer. From the equilibrium position x naught is equal to under root a by 2. From the equilibrium position you displaced it by distance of delta x. Right? Your final acceleration should be directly proportional to delta x. Open up this bracket a plus b whole cube, neglect the higher powers of delta x, you get the answer. A link, डाउट्स का लिंक आज ही मुझे चाहिए, वो अपलोड करने का वेट नहीं करने का, बाकी सेक्शंस को लिंक भेजना।
जो यहाँ से स्टार्ट होता है JEE Advanced उसमें फेजर एंगल प्लस पावर 2 करना है प्लस पावर 2 के
वही तो करेंगे
दोनों के कोर्सेस
Sir, exercise 133rd question.
Wait, let me complete this first.
नहीं पर यहाँ सोचना ज़्यादा आसान है, फिर तू यहाँ प्रोजेक्ट कर ले तो गलती हो सकती है, देख लेना।
20th, conserve momentum. M is falling from here, and from here what is falling? Draw from the ends of the mass collide and stick to each other and perform SHM. See, C is 2m, right? Collision, conserve momentum, m into v1 minus of minus 2m into v2 will be equal to m plus 2m into v0. Once I get this v0, half 3m into inelastic collision, right? Perfectly inelastic collision. Equate this to half 3m omega square a square. Omega you know is under root g by r. Find out a.
Sir, here can we use binomial x naught plus 3? Q cube x naught.
In a simple pendulum.
Sir, after this time, even after that, omega will be.
See, as the level of the water is going down, the level of the water is going down, the center of mass is increasing. The center of mass is going down, length is increasing, 2 pi under root L by G. As the level of the water is going down, you will see that the center of mass is going down. Center of mass is going down. As this is getting emptied, beyond the last stage, center of mass will start coming up. So when the center of mass is going down, L is increasing, time period will increase. But once the container becomes completely empty, center of mass will come back. Center of mass comes back, you will get back the same time period.
Thrust force.
कहेगा thrust force.
Mass नीचे जा रहा है, thrust
So
वो कंसीडर करके
small bob no yaar, usse water is dripping out, water is not ejecting out. You are not pressing it, thrust force will be very minimal.
And it will be along the string every time.
Right.
G factor थोड़ी matter.
Listen.
Sir, exercise 5, question 17.
Question need to be discussed this way. Thrust we will not.
Sir, 31st एक बार वापस बताएं.
31st, the level of the water is going down. If the level is going down, center of mass, say you will take L. So center of mass is going down. So length is increasing, time period will increase. Beyond a stage, it will come back to the center of mass. So it will come back to the same length and hence the same time period. First, two particles, the system same amplitude, and one particle is at the extreme position. One particle is at the extreme position, the other is at the mean position. They move in the same direction. That means the phasor में आप लोग डिस्कस कर लो उसके बाद क्लियर करूँगा. Finish up. Say one particle is at the extreme position. The other is at the mean position, both moving in the same direction. Then you may ask, I am drawing the phasor. Then you may ask, will this particle be here? It could be here also. Not possible. If the particle is here, the foot of the perpendicular will be going up. And he is telling you both the particles are moving in the same direction. So here the particle is going down, here also the foot of the perpendicular is going down. So these are the two particles. The phase angle between them is pi by 2. What does it mean? They will cross each other after a further time of so y I will take as a sin omega t plus pi by 2. Y2 is equal to a sin omega t plus pi. Now what is the time after which y1 is equal to y2? What is the time after which y1 is equal to y2? Is that all? Did you get the answer from that? Simple straight hit, right? The phase difference between the two is pi by 2. Utna yaad rakhe. Time after which y1 is equal to y2. Equate y1 equal to y2, you get the answer. End of a spring executes a simple harmonic about an equilibrium position with an image. Speed as it passes through the equilibrium is v. If extended to a and released, speed of the mass passing through the equilibrium position. See, listen, equate kinetic energy to potential energy. Half mv square is equal to half k a square. If you increase this, amplitude also will increase. 25th question. Kinetic energy, mean position, extreme position. Total energy should remain constant. Mean position, extreme position. Total energy should remain constant. Suppose I increase this by 2v, proportionally increase the amplitude. Time period is 2 pi under root mu by k. Now when I am taking m1 here and m2 here and both masses are connected, they will go from maximum compression to maximum elongation to maximum compression. But in this problem they played a practical joke with you people. They didn't connect this body. They said this is it. So right from the time this comes here, that is the natural length of the spring. From natural length you will go to maximum compression and back to natural length. You will never have maximum elongation. But when it comes to natural length, this will leave contact with it. So half this time period. From natural length you will go to maximum compression. You cannot come back to maximum elongation because the moment it crosses the natural length, this will leave contact with this. The spring is not connected to this mass. Right? So time period will be half that particular one.
So can you please explain this again?
Here this mass is not connected to the spring. Half the way through, whenever this comes to natural length, this will leave contact with this. So maximum elongation kabhi nahi aayega. This will leave contact with this. So it is from maximum compression to the natural length to maximum compression again. So time period will be half of it. 33rd one.
Yes, sir.
33rd. If I give Q, I will have induced minus Q here. If I give minus Q here, I will have induced charge Q. So either way there will be force of attraction only. Force of attraction means time period will be 2 pi under root L by G effective. G effective will be G plus EQ by M.
Sir, nahi sir.
If I have given Q here, I will have minus Q induced here. If I have given minus Q here in the metal, I will have plus Q. Either way there will be force of attraction only. So
Sir, how do we know कौन सा charge induce हो?
Opposite charge ही induce होगा ना यार.
Sir, question 16 might be out.
Okay. 43. Simple pendulum, length L and mass M of the bob vibrating in amplitude A. Then the maximum tension in the string. Maximum tension in the string will come when the bob is at the lowermost point. T minus mg is equal to mv square by L. Loss in potential energy is gain in kinetic energy. Amplitude वो ये बोल रहा है. He's telling you this is A. Right? This will be L minus A. This will be L. Right? Loss in potential energy mga is equal to half m v square. This V you substitute here. Amplitude वो A बोल रहा है कि ये बोल रहा है? Amplitude means he'll take this then. If this is A, then it's a direct hit. If he gives you this as A, which I don't know, please verify both. Find out this height. If this is amplitude, please find out this height. And then substitute. Right? Is it clear? We will have to specify which is the amplitude here. Probably this will only be taken as amplitude, not this. Find out this. Find out this height and substitute here. If I take this h, take this h. Then listen, you don't need to do all this also. Put V is equal to A omega. A is the amplitude. That means this is only A. At the bottommost point, V will be maximum. Maximum V means V maximum is equal to A omega. Is right?
Sir, exercise 5, question 70.
1 second, wait. 45th. Exercise 1. 45th May, you have a time period for this. Now, you kept this. This is the natural length. So, it will go up, come down and come down. For this part of the journey, time period will be pi under root m by k. For the upper part of the journey, for this part of the journey, time period will be pi under root m by k. Right. For the lower part, you have here also k. Both are k's. Here also k. Now for the lower part, there are two springs in parallel. Right. So it will become 2k. Lower part, it will be pi under root m by 2k. Add both the time periods, you will get the time.
Sir,
40.
40.
Now listen, a very typical problem from Morin says, a tunnel is dug through the diameter of Earth. What we solved is a point mass is dropped from the north pole of the tunnel, which will go to the south pole and it will perform SHM. Now Morin says he kept a thin rod of linear density lambda. The rod is slightly displaced to the right and released. The rod is slightly displaced to the right and released. Length of the rod is 2r, 2 times the radius. Length of the rod is 2r. Now the rod is slightly displaced to the right and released. Find the, make it very fast.
Sir, 2 pi into under root r cube by GM.
R cube by GM. Wait, I don't remember the answer. I will solve it. Wait. लैम्डा भी आएगा यार आंसर में. हाँ, लैम्डा भी आएगा आंसर में. सुनो, I'll give you a hint. सब लोग सुन लो ना यार. Listen. At the center, this distance is r minus x. Agreed? To a distance of r minus x, the force on this part and this part will get cancelled out because इस पर E inverse है, इस पर V inverse है. Right? So मुझे इसके बाहर का इस पर force और इस पर force calculate करना है. I'll have to calculate the force on this leftover part. What will this distance be? X, and this will be x. Now calculate the force on this x and this x. You get the answers. Add both of them.
That was for a point
mass. Come again? Yeah, I'll come to that. Finish off this problem, I'll come to that.
So how do you find the force on that small x that is outside?
Consider a small element of dx at a distance of x, or call it y at a distance of y. At a distance of y, right? df will be equal to integral g capital M y by r cube into dy. Least value of y is r minus x to r plus of, right, into lambda dy. This is the field, this is the mass of the small element. Now come to the part outside. On the part outside I will do the same thing. Gm by part outside will be y square into lambda dy. This will go from r to r plus x. Y is a variable for us. G capital M by y square will be the field outside the sphere. Inside the sphere it will be this. Equate this to mass into acceleration. What will this be? mass into d2x by dt square. Mass will be lambda into 2r. See if all of you are getting.
Sir?
Yeah.
So when we are integrating separately for the inner and outer part, so the part which is on the boundary, are we calculating it twice? Like separate values when we add it? So because first integration the upper limit is r and the second limit lower limit is r.
Actually we never have a problem with it. See, this will end at r, this will start at r. Right? Suppose you want to differentiate between that, then I will have to take some limiting values for r here. R minus delta x, r plus delta x, so on. That will make no difference because limit delta x tends to 0. Right? The value of the mass at the boundary is not spreading, it is at one instant. So that won't be a problem. Tell me what is the answer for this, make it fast. Verify if all of you are getting the answer. I don't know the answer here. One of the students got this answer. Simplify that. Okay, listen. One or two small things left over in this subtopic. 1 second, all of you listen. Solid sphere with a cavity.
X and Y लेना, X and Y का picture ऐड करके आ रहा है वो कौन?
So you know the field inside the cavity of the solid sphere. We dealt with. Yeah. Okay.
So last time we were given a question.
What is the mass of this?
16 m 2a.
2a.
M and D.
M and D. Distance between the centers is 10a.
M small on 16.
Now on 16m you have a mass here m, which should be projected with the velocity u. They are asking you what is the minimum velocity I should project this so that it reaches this particular star. Now remember, somewhere in between the field will be 0. Somewhere in between the field will be 0. You need not send it with the velocity for it to reach here. If you can just make this cross this, it will be naturally pulled into it. Right? So first find out the point where the field will be 0. I take this total distance to be x. This will be 10a minus x. Right? G into 16m by x square is equal to G into m by 10a minus x whole square. 10a minus x into 4 is equal to x. 40a is equal to 5x. X is equal to 8a.
Yes, sir.
So x will be equal to 8a, this will be equal to 2a. So technically, if this is the diagram, this is the diagram. At this point the field will be 0. This is 8a and this is 2a. This is 16m from here I should project this mass of small m with a velocity of u, so that it will just cross this particular point. So that it will just cross this particular point. Are you clear about it? Now, what will be the total energy here? Half mu square minus g 16m by 2a into small m. This is the potential energy between small m and 16m. Plus of, don't forget the potential energy between capital M and small m. It will be minus of g capital M small m by distance from here till the center will be 8a. Because this distance radius is 2a and the total distance is 10a. Equated to kinetic energy at this particular point will be 0. It should just reach this point. Minus g 16m small m by 8a minus g capital M small m by 2a.
Sir, why should it just reach that point?
If it just crosses the point, it is surplus, it will be pulled into the star. You need not give energy for it to reach that. If it just crosses this point, it is surplus, it will be pulled into the star.
Sir?
Sorry for Earth's rotation.
Sir? Sir, would you consider that the two planets are also attracting each other? For that, would
No, that has been given in the question that for the sake of the problem, you can consider both the stars to be stationary.
Okay, but sir, like I was thinking, sir, that if we consider it as moving, so sir, can't we just, if we don't give escape velocity to the smaller mass, I mean the planets will attract each other and more at a particular time. The smaller can get attracted by the other planet.
Two stars will never exist this way. They will start moving into each other. So the only way in which they can exist is they are oscillating around their common center of mass. So this is called a binary star system. Take this down, I'll drop the book.
Okay.
RQ by GM may be right. I don't know the answer.
RQ by GM center of mass लेकर भी same वही आ रहा है. Coincidence or something?
Coincidence. Few students for the previous problem of the thin rod, they are getting omega is under root R cube by GM. Please see, we don't know which one is the answer. I don't remember the answer. The thin rod oscillating ka omega, some of the students here are getting
GM by R cube.
under root GM by R cube. Can I rub the board?
Yes, sir, we are also getting the same.
Okay, R cube by GM. GM by R cube. Now listen. Binary star system. This will be M1, this will be M2, this will be R1, this will be R2. Two stars are not hinged to something in space. However massive the star is, and the more problematic is, the more massive the star is, the more will be the force of attraction. So the two stars are not hinged to anything. So they can never remain at rest. Two galaxies are not hinged to something, they'll start pulling into each other. So both are going around their common center of mass. R is equal to R1 plus R2. Right? Net total distance. Second, M1 R1 should be equal to M2 R2. How are you telling me that? The position of the center of mass should not change as we are not taking external force on it. Right? The other way of looking at it is G M1 M2 by R square provides the required centripetal force for this as well as this. So M1 centripetal force omega square R1 should be equal to M2 omega square R2, and hence I will get M1 R1 equal to M2 R2, right? So this provides the required centripetal force. I will take this as the first equation and this as the second equation. I want R1 and R2 in terms of R. Now it will be R is equal to M2 R2 by M1 plus R2. This will be M2 plus M1 by M1 into R2. R2 is M1 by M1 plus M2 into R. Similarly, R1 is M2 by M1 plus M2 into R. Agreed? Substituting R1 and R2 in any parameter, I can calculate the net total values. Have a look at this. You are calculating angular momentum of the system. Angular momentum will be I omega M1 R1 square omega plus M2 R2 square omega. What will R1 be? M2 by M1 plus M2 whole square omega. M2 by M1 plus M2 whole square omega. I'll have an R inside. This will be M1 M2 by M1 plus M2 R square omega. Do you recognize this? Mu R square omega. A two-particle system without an external force, I can always use the concept of reduced mass. Can you make a guess as to what will the kinetic energy be? Calculate. Kinetic energy, how will I calculate? Half I1 omega square plus half I2 omega square. I1 is M1 R1 square, M2 R2 square. Substitute R1 and R2 and see what you are getting. JEE people already asked you once to calculate angular momentum. They didn't ask for kinetic energy.
Same. If I take omega square by 2 common, it's the same expression.
Half mu R square.
R square.
This is called a binary star system. Look at the beauty in the Creator's universe. All of you, 1 second listen. The universe is continuously expanding. Statement true or false?
Not true.
True. Universe is continuously expanding. Right? Then why doesn't the distance between Earth and Sun increase? When I was a kid also, the distance between Earth and Sun is told the same value. Now also we will tell you the same value. Look how much of a care has been taken in whole of this system. And one more typical doubt. I used to have this doubt for years. In my childhood they used to say, your galaxy's definition, Milky Way galaxy and all this, right? Now the biggest doubt I used to have is, the distance of the nearest star from you is always the same value. Andromeda's distance from your galaxy, they'll always tell you the same value. Speed at which universe is expanding once upon a time was an abnormally high value. Abnormally high value. It's not small. Abnormally high to such an extent that suppose if I take the universe expansion this way, light from this end of the universe will not reach this end of the universe because the relative speed at which it is expanding is greater than the speed of light. How do you make a guess as to what is the diameter of the universe? Light from there hasn't yet reached you. When the universe was born, it started expanding. The expansion rate of this is so high, greater than the speed of light, that the light from here is not yet reaching us. Right? I am moving in this direction with a velocity v, and I throw a body in the backward direction with a velocity lesser than mine. So effectively I am moving in this direction. Light from one side of the universe doesn't reach the other side of the universe. That is the reason why for us our night sky is yet dark. If not, 5 to 6 bulbs in this room is glowing with so much intensity. Million stars in the universe. Look at the intensity of, and our sun is a small star. Those big stars, so much of a light, whole of the universe would be glowing whole day and night. There will be nothing called night at all. But why doesn't that happen? Means from the farthest galaxy light yet is not reaching us. We are moving at a much faster rate. Now in such a creation, how is it the distance between our neighboring galaxy and us always remains constant?
Sir, if I
It doesn't, right?
So, if I go by the conventional definition of gravity, if I have a stretched membrane, I put two masses in it.
Now listen. When you are speaking about the universe expansion, it seems it is expanding as though a balloon is expanding. Universe is not a point source which is expanding radially outwards. If you blow balloon into the air into a balloon and there are two dots on the universe, on the balloon, the way the two dots are moving away from each other will be the way in which galaxies are moving away from each other. Inside a galaxy, stars' distance will remain constant. Inside a galaxy, the distance of stars will remain constant. So they played, how did they define the boundary for a galaxy? Who are the people who decided boundary for your galaxy? In your galaxy you have so many stars. Neighboring galaxy you have so many stars. Why? How do you know that this is the boundary line? That is neighboring galaxy and this is my galaxy. Who drew the boundaries? Creator himself drew the boundaries. Two stars within one galaxy will not be moving away from each other. Planet from the sun distance will remain the same. They will not be moving away from each other. Center of mass of one galaxy will be moving away from the center of mass of the other galaxy. Distance between two galaxies is increasing, not radially. It's like a balloon expanding. Right? It's like a balloon expanding. And two stars within one galaxy, you will not experience any increase in the distance. So when you realize that all these stars are fixed to a particular center of mass, you call them stars in one particular galaxy. Look at the amount of work that must have gone in collecting the number of stars. You know your Milky Way galaxy has got so many million stars that recognizing the another galaxy will be so very difficult. It's a laborious process. Don't disconnect it. Take it down, take it down.
Sir.
THANE.
Sir, you said that the universe is not illuminated because the light from one end of the universe does not reach the other. But there is existence of dark matter also, right?
Dark matter altogether is a different perspective. We yet don't have consolidated proofs on it. It's only theoretical. Right? Neither do I have an idea on dark matter.
Okay, sir.
Sir, can you please explain the first equation again?
First equation, center of mass. First equation is M1R1 equal to M2R2.
So why did you take the omega to be same?
If the omega is not the same, position of center of mass will change. When this comes here, this will come here. If this is M2, this is M1. The angular displacement should be the same. If they are not, position of center of mass will change.
Okay, sir, thank you.
Sir,
Sir, when so much work is done on in the form of documentaries and all are related to Mars, why can't human?
Somebody switch off the mic. Why can't human?
Keep it up. Don't start again.
Why can't humans go there?
They are trying, right?
They are planning a land mission in 2033.
They are trying.
Okay.
Sir, can you explain how multiple star system works?
It does no work.
How they work?
दूसरा समझने में इतना टाइम लग रहा है।
उसको फर्स्ट इक्वेशन समझनी है।
Why do black holes have exceptionally high gravity?
It is because of mass. Take this down, I'll explain.
So I have inside a black hole, try resource.
Now listen. When you are speaking about a black hole, this is the way a star is actually formed. Formation of star is when hydrogen and helium atoms in space. In space there will be free hydrogen and helium atoms which will start attracting because of gravity. Slowly it will start from a point object. Slowly the attraction continues. Gravity may, do you mean to say two hydrogen molecules this way will start getting attracted towards this? Yes. Such a small attraction, how will it sustain? There is nothing opposite to it. Right? Place Mount Everest on a frictionless surface, I can move it with a single finger. So now there is no opposing force. So the accumulation process will continue. As the accumulation process continues, what gives birth to a star? Two hydrogen atoms, when they fuse into each other, this is called fusion. So-called hydrogen bomb that you speak of has got fusion reaction. Fission is splitting of a bigger nucleus. Fusion is taking two nucleus into one another. Fission and fusion reactions will be taught to you in nuclear physics and nuclear chemistry. Now, the pressure or density, this accumulation process will take few million years. Accumulation process will take few million years. And then two hydrogen atoms inside, because the pressure, merging both is not easy. You need abnormally high pressures. Why? Because the nuclei of both the hydrogen atom are equally positively charged. As you bring them close, they will repel this way. Try to bring two bar magnets close, they will repel this way. Same north poles. Two positive charges close, they will repel this way. Close them in all the directions and forcibly merge two of the hydrogen nuclei. It will give birth to fusion. One fusion reaction is so very huge that it can cover almost 1/4 of our globe. Right? That is the amount of energy with one fusion reaction. This fusion reaction will throw this mass outwards. Again, the gravity will start pulling in. Gravity doesn't have an age. Gravity will act universally. The process continues. Gravity starts pulling in. Now a few hundred fusion reactions will take up simultaneously. It will throw this mass out. Mass will start coming back due to gravity. Then at some stage there will be an equilibrium set between these forces and the gravity. The nuclear forces which are throwing the gases outwards and gravity are balancing this act. That is during that time that the star exists in its lifespan. That is a few million years, billion years say. Right? Beyond a stage what's happening? Two hydrogen or four hydrogen nuclei will merge and give me helium. Two helium also, if the density is abnormally huge, maybe two helium will merge into each other and give me carbon or oxygen. One second. Right? So, this will give rise to carbon. Carbon nuclei merging is impossible. How much ever density you give. Hydrogen nuclei merging itself is quite difficult. Carbon nuclei will be abnormally high. Right? Now this merging is impossible. So beyond that what happens? There will be no more merging. Gravity will exist. But the nuclear fusion rates are going down. Because the star is running short of hydrogen and helium. Carbon will not fuse into each other, impossible. So then, as the nuclear fusion fuel is going down, right, gravity alone will be dominating. If the gravity is dominating, the star will start shrinking. if the rate of shrinking of the star crosses Chandrasekhar limit, Chandrasekhar was a person who calculated this, and if it crosses this limit, the density of the star will be abnormally huge. What did you calculate escape velocity as? 2 gm by r. Am I right? Mass of the star will be density into 4 by 3 pi r cube. So the escape velocity will be directly proportional to density. If the density crosses Chandrasekhar limit, rate of shrinking crosses Chandrasekhar's limit, then the density will be so high that the escape velocity will be greater than 3 into 10 to the power 8 meters per second. The moment escape velocity reaches 3 into 10 to the power 8 meters per second, light is also pulled back into the star. Now, first time, when did we understand that light is attracted by a mass? Gravity applies to light was something which was not accepted initially. Ironically, first Einstein gave birth to special theory of relativity. General theory of relativity comes after that. In his general theory of relativity, he proposed that light is attracted by gravity, which people didn't accept then. Slowly, with the evidence of experimental proof, they started understanding that yes, light is attracted by gravity. That too how? Because they were here. There is a black hole here. There is a star here. Light should come straight from the star towards us, but in fact light is bending this way. That means we are assuming the star is here while the star is actually here. So the black hole is actually attracting light. Right? Black hole is actually attracting light. So this attraction tells us that the position of the star is at a different point. Then they understood that there should be some black hole here. As on date, there is no experimental evidence of the black hole. The observations of bending of light is making us feel that there is a black hole there. Nobody ever proved the existence of a black hole. Dark matter, black hole, all these are theoretical concepts based on the predictions. For that instance, 90% of particle physics, 90%, you have got so many particles in particle physics which are not actually observed, they are only predicted. Neutrino, did you ever watch a neutrino? No. Then why did you propose a neutrino? In beta decay I am unable to conserve momentum. Conservation of momentum is compulsory. So there should be some other particle coming out, which you have not observed. Propose it, neutrino. Then what in a beta capture? Anti-neutrino. तूने कभी देखा है anti-neutrino को? नहीं. Then why did you propose it? Conservation of momentum is compulsory. 90% of particle physics and cosmology goes on the predictions this way. Not all of them have experimental evidence. एक particle they have discovered called boson. They made so much noise about it. Stephen Hawking said the world will not change even if they observe boson. Actually nothing will change because there are so many other particles which they should find out yet.
In nucleus के अंदर से इलेक्ट्रॉन निकलते हैं न्यूट्रॉन दिखता है how far मिला है 10 टन में था ये रेडिएटिव
Now listen, you have a question to ponder on. This is Earth, this is the Sun. Think carefully and bring the answer in the next class. 2 questions that you will have to discuss. HCV is asking in his reasoning questions, mid-known force due to Sun is in this direction, force due to Earth is in this direction. This is normal force. Mid-known normal force will be force due to Earth minus force due to Sun. Your weight in mid-known will be this. Your weight at midnight will be force due to Sun plus force due to Earth. N is equal to force due to Sun plus force due to Earth. Normal force is force due to Earth minus force due to Sun. Here normal force is the sum of the 2 forces. Right? That means your weight during midnight and mid-noon should be different. Your weight during midnight and mid-noon should be different. Did you ever weigh yourself at midnight and mid-noon?
No.
Provided you have the same quantity of lunch or dinner, your weight will be the same. Be assured of it. What is happening here that you are getting different values? Is the question clear?
Yes.
Second question. You will take down these questions and work on it. This is Earth. This is the moon. I was told in my schooling in geography textbooks that moon is the root cause for a tide. I used to die trying to understand this. So during midnight, moon is pulling the waters is understandable to me. Then why should I have a tide in the mid-noon? Ever go to Marine Drive afternoon 1:30? Why 1:30? Go at 12 no here. At 12 India will not see a tide. India will see a tide at afternoon 1:30. Why? Because India is not on the equator. Right? So go at 1:30, you will see afternoon also a tide. Night 1:30 also you will see a tide. If moon is the root cause for the pulling, why should you have a tide on the other side at mid-noon? According to the geography textbook, if moon is the root cause for the tide, I should have a tide every 24 hours. I am having a tide on the earth every? Why? Sun. But geography textbook doesn't say sun is also contributing to the tide.
Sir, that's why I got geography.
Right? It is only the moon who is contributing to the tide. How? Are both the questions clear to you?
Yes.
Come to the next class with the answers for this. Search every possible source that you have got. Clear?